I like that the students are coming in with kind of fresh eyes and a fresh mind to think about new materials and like anything we're throwing at them. Like even recently, we started off with this really heavy kind of like theoretical reading to set a tone where we could quickly start talking about larger ideas. Because I think as we work through any of the classes, there's always this kind of philosophical idea about thinking about creativity and where does it fit in the world. I think it's a fundamental way, like another like language to kind of like interface with anything around us. But I think the overall picture here is that we're learning how to kind of think in abstract ways and creatively problem solve. And the more exposure you have to materials and tools and ideas, the more well equipped and like more of an asset you'll be to like any industry, any job. You're always going to be that creative in the room, and I think a lot of people are looking for that. Here at the Wingate Center, you really get the one-on-one attention that I think students deserve. I hope you've enjoyed the other demos. My name is Ben Dory. I'm the artist in residence in metals and jewelry here at UA Little Rock. Today we're going to talk about casting, specifically lost wax casting. So we'll use a number of tools. We'll use this kind of oxyacetylene torch. We're going to prepare the casting here. This machine is a vacuum caster. So we'll pour the liquid metal over here. Before that, we'll pour a mold and we'll mix investment, which is like a high temperature plaster. This kiln right now is at about 1,000 degrees, and there's a flask in there right now that's ready for the molten metal. And then over here is kind of a work prep area where we have all these different flasks, and these will fit into the machine so a vacuum can pull the molten metal into the mold. Okay, so before we dive into the processes, what is lost wax casting? It's been around for thousands of years, say 4,000 or 5,000 years. And really the premise is to take, well, in this case, a wax mold, or in this case, a 3D printed mold. And you want to transform that wax or that resin into metal. So for this particular case, we have this 3D printed tree, and this is called a Sprue Tree. And the idea is when you pour the metal upside down here, all these branches will be avenues for the metal to flow. And in the end, you end up with rough casting right here, and this is slightly cleaned up. And then eventually we get to this one with the stone setting. Now, it is possible to set the stones in place before you actually cast it, and this kind of alleviates a lot of issues later, but it takes a different approach. So as you work through casting, you can strategize like how you want to make your jewelry, how you imagine the jewelry. And then overall, casting in general is just another kind of technique for creating the kind of like the wearables that you want. So the real benefit is that you can make multiples. So in other metalsmithing classes, we start with wire and sheet metal, and you learn how to solder and braze and kind of fabricate the whole piece. But in this situation, we're 3D modeling and we're carving wax, and it's just a very kind of different way to go about the whole process. And there's a big difference between, say, like the studio artist and then the more kind of industrial artist. So like a lot of wedding rings in the world, like those would be mass produced and cast by the thousands. And then it's the unique part is what stones you choose, the story you put into it. But again, that idea of multiples really makes sense, especially on a large scale. Here's another project right here. So this is a 3D printed model as well. And this project was interesting because I asked everyone to design a monogram. So we carved it out of wax first, and then we 3D modeled it, and then comparing the handmade object versus the digitally created object, like one's very precise, but it's lacking that kind of like human element. So maybe like the human error in craft and in making, maybe that's the part that really speaks to us. And then this is our casting grain right here. And this is just shot, right? So all these come in like a lot of specific alloys. In this case, this one's called alpaca, and this is a blend of copper and zinc and nickel. So technically it's a brass. And we'll look at the temperatures back here once we start warming it up. And then when we pour the actual molds, we have these two types of flasks. So since the machine that we're using is a vacuum casting machine, you can use this flask, and all these holes right here allows the vacuum to pull the metal through, this like porous investment or the plaster. Or on the other hand, you have a solid flask right here. And this one can go into a centrifugal casting machine. So this is where you would wind it up and the force would throw the metal into the back of it, but it also works with the vacuum casting system. So this one on the right is what we're going to use today. All right, so how do you prepare everything? So after you carve the wax or you have your 3D model, you make what's called the Sprue Tree right here, right? So again, you have all these avenues, and when you actually pour the metal, it's going to be upside down, and all the metal's kind of flowing through. But then there's a little bit of math. It's not too crazy, but you have to figure out how much metal will replace the wax. So to do that, you find out what alloy you have right here, and we use something called specific gravity. And specific gravity is just the kind of the relative difference in density between two materials. So usually the kind of like normal or the base material is going to be water, and then that would be 1. So conveniently, wax also has a specific gravity of 1, or it's the same as water. So when we look at alpaca and we see that the specific gravity is 8.4, it means it's 8.4 more times as dense as water or wax. So all you have to do is multiply, like you'll find the mass of this wax, and I think this one was around 2 grams, and you would multiply it by the specific gravity, and then you add a little bit more just for insurance. So all that's been calculated, and then over here, everything's kind of set up, and this is the amount of casting grain we'll need, so not too much. And we're going to melt it in the crucible right here. All right, so everything's prepared and in the kiln, and before that, we need to actually prepare the mold. So over here on the right, I'm going to mix some investment for you. Okay. So we have this kind of roughly weighed out. So investment often is weighed in pounds. If you wanted to be really precise, you would use metric, grams, find the mass of it. And then there's the specific amount of water right here. So what we're looking for is a very like pourable plaster, and it's going to be something similar to maybe like pancake batter. And I'm going to mix it with my hand. So you can do all the kind of like math in the world, but like nothing's going to tell you whether the consistency is right more than your kind of like feel of the whole process. All right, so I'm going to add water in here, and then if you're mixing plaster of any sort, you always want to add the plaster to water. And if you do the opposite of that, you're going to end up with a lot of clumps, and it's just harder to break down. So generally, if I wasn't wearing a microphone, I would absolutely be putting on a mask right here. Plaster has a lot of silica in it, and that's just something you don't want in your lungs. Okay, so I'm just going to gradually start adding this in.
Someone's asking, how do you learn to do this? Because most high schools don't have classes like this.
Right. Okay. So how did I get into this? How did I learn all this? I happened to go to a high school that strangely had a jewelry program. And what we did first, because largely it's the most approachable, was carving wax, and then our teacher cast it for us. So we talked about jewelry, we talked about process, but we didn't go through the actual mixing of investment or casting. So in classes here, at the very beginning, I do every step with everybody, but eventually I want everyone to feel comfortable doing all these things on their own or with a partner in the studio. If you really want to kind of like dive into this world, the newly minted Arkansas Museum of Fine Art in town here has casting classes, and then a lot of craft schools will. And then hopefully we'll be doing more things like this, so you can pop in and learn. There's so many tutorials online. YouTube is always a great resource. And then even like your local jewelry store, if you're really kind of bold and curious, go talk to them, ask them about casting, ask them about the process, and often they may need a little more help. Okay, so mixing with my hand, it has this kind of viscosity to it. There's a thickness to it, but it will still pour. All right, so I'm just going to rinse off my hand here.
Are students able to show their work and sell their work?
Are students able to show and sell their work? Absolutely. So we have galleries in the building. There's student competitions. We have visitors who come through the classroom. And for my part, I stress kind of technical process, and then that's just something through repetition you're going to learn, but also design skills and marketing. And I think in the end, everyone would love to sell their work. So we talk about strategies for going about that. Okay, so now I'm going to move over to this dome right here, and this is a vacuum chamber. So the idea is that as the vacuum pressure grows, it's pushing down on the investment, and as it pushes down, it's pulling all of the air bubbles out of this. So another benefit of mixing with my hand is that I'm limiting the amount of air moving into the whole kind of system. I'm going to put this down. Because what happens inside the mold, if you pour investment with too many air bubbles in it, then it'll stick to your model, and you'll have a perfect little sphere of metal in the end, and you'll have to clean that up. Okay, so I'm going to get this centered inside of here, and it's on this tape just because it has a narrow base, and it'll keep it steady. All right, so here on the right side, I don't know if you can see it on the camera, but there's investing, which happens over here, and then the casting vacuum, you'd flip the switch here. So power's on. I'm going to turn on the pump, and we can see this rubber underneath. It raises up because of the pressure. And then what starts to happen inside here as the vacuum increases, it turns into this kind of like active froth. So this is all the air being pulled out of the investment.
What's the most expensive piece you've ever made?
Oh, it's always a fun question. I think the most I've sold a piece for, and it was a sculpture, was $2,000. And then jewelry-wise, like hovering around $1,000. But again, it's like it's been years and years and years of developing a style and a technique and something that I find and other people find kind of unique in the field. All right, can you see inside the? All right, so it's like bubbling almost to the top here. So if you've ever made bread, like a really active kind of yeast, there's something similar to this, like an over-enthusiastic dough. So I'm going to let this run for about a minute, and then what I've done here is put it on a rubber base, and I have my two models here centered in the middle. So that's a great question about pricing and markets, though. I mean, on some part, you have to feel really comfortable with your product and your price points. On the other side, like knowing like who would want your work, right? So your kind of your audience, your target market, and then that's going to drastically affect your prices. So I have anything from a production line, which is a lower price, to custom and commission pieces. All right, so I'm going to pour this down, and I'm not going to pour it on top of the models here, but down the side.
Someone said you had some work done in New York City recently. Is that true? Can you tell us about it?
Let's see. I think most recently I had work in New York Jewelry Week, and that was in 2019, so pre-pandemic, and yeah, it was wonderful. It was an honor to be a part of all that. But a gallery that represents me had a showcase at New York Jewelry Week, and they took my work with them, and it was a real pleasure. Okay, so I haven't filled it up all the way here, but I'm going to put it back under the dome. So I mixed the investment, debubbled it, and then I poured it, and I'm going to debubble it again. And jewelry is just wonderfully portable too. So to send work to New York or across the country, it's not that big of a deal to pack it up. And then sometimes you start to build a relationship with galleries, collectors, anyone really interested in your work. And like once you have that rapport and that relationship, you could send them work to try it on, to size it, to see if they like, say, like the color of the stones or the weight or the feel of it. And it's a really kind of rewarding experience to have this kind of national network of people who are like excited to see what's new and what you're making. So I really try to like always be pushing a new technique or a new concept to keep it, well, it's interesting for myself, but also for anyone who might be curious about the work. All right, can you all see this one? All right, so this is what it looked like inside the flask. So we have these big bubbles, and it's not nearly as active as it was before. So that means we've pulled a lot of air out of this already. And then just in case there are air bubbles trapped on one of those rings in there, you kind of tap it on the side here. And I'm looking for the surface to be almost inactive. There's always going to be small bubbles around the ring or around the edge right here. But in the middle, you can see this big bubble just has pretty much become stationary. So at this point, I'm good to go. Absolutely. You know, and this is something I talk about all the time in school, like drawing, sketching, ideation. I think the more you can have a sketchbook practice or just a drawing practice, or it might be writing, but there's something to get your ideas out. It's more about kind of documenting your thoughts because you're not going to remember everything, right? So you can always go back and kind of, you know, find something that you forgot, but it still might be a great idea. And that happens all the time. And then also drawing in a sense or sketching where you're not making beautiful illustrations necessarily, but it's more about communication. So especially if you're talking to a client or a friend or just trying to share what's on your mind, that visual representation of what you're thinking about goes a long way in kind of like passing on that information. Okay, so this flask is ready. I'm going to pour in the last little bit on the top here. And then by the time this demo is done, this investment should be set up. I'm just going to lay it off to the side right here. Okay, so now the drama, the fun part. Let's talk about torches. So this is a real kind of intense hot torch. We'll use all sorts of torches in this studio. The primary gas that we use is acetylene. And acetylene is really hot, really volatile, and it's really dirty. It's really sooty. So to mitigate that, because you don't want to be pushing a dirty flame onto your work. So the more the metal oxidizes, the more issues you have in casting or soldering, but also the more you have to clean up later. So the way torches are set up, we have our acetylene here, and these are always going to be color-coded. So your fuel line, whatever it is, propane, acetylene, etc., is going to be the red line. And then oxygen is always green, but often whatever the enhancing flame is will also, excuse me, hold on to that. So whatever the enhancing flame is going to be this green line right here. So what it's going to do is going to take maybe the acetylene flame, which is already extremely hot, and it's going to boost that temperature even higher. And the same kind of idea happens, like, so if you're grilling the charcoal, when you have airflow going into it, it's going to make it hotter and enhance the flame. And you can change out the tips on these. If you're doing like big work in a machine shop, you're going to have a rosebud on here. And the rosebud has a circle of smaller holes around, and then that just covers more area, but you also get this enormous flame. And then sometimes there's a handle on here you can push, and that's for a cutting torch. So you can do all sorts of things with these types of torches. Connect metal, cut metal, just heat things up, bend it. All right, so how we light the torches, these are something to kind of get used to. So we'll use strikers, so it's never a good idea to use a lighter. Although the lighters do work, you have a little tiny bomb in the studio next to your 2,000 or 3,000 degree flame, right? So the striker's nice because just a spark is enough to light the whole system. Okay, so in the casting process, we also have different types of crucibles. All right, so we have this wider one I'm using today. We have this one, which is kind of a tiny version of one you would use for large-scale casting, like outdoor foundry casting. And what you might see most often in jewelry studios is something like this. All of these are made of a certain type of mix of gypsum and silica and like really high-temperature ceramic. And then the inside, you can see that they're kind of glossy, and it's coated with flux. In this case, it's borax, and this is just the stuff that you would get at the grocery store, so like laundry aisle. But when you heat up borax to a certain temperature, it becomes a glass. So to prepare these crucibles, you line the whole thing with glass, and the idea is that the ceramic part is porous, and you don't want your liquid metal to soak into your crucible. You also notice that there's a couple different colors here. And it's really important to separate out your crucibles for different alloys. So 14 karat gold, 18 karat gold, bronze, brass, the whole deal. So this one is for bronze, and it has a high copper content, and then this kind of relates to ceramics. But when the copper oxidizes, it's going to turn this red color. Now, oh sure, so what is a crucible? So the crucible is just this little bowl. So, and kind of like specific to metalwork, whether it's sculpture or jewelry, this is how we're going to melt the metal, and it's how we're going to pour the metal. So kind of like separating out the metals between the different crucibles. And then this one has this kind of gray tone to it, and that's because there's zinc in this alloy. And that one's really important to separate because zinc added to other metals is going to lower the melting temperature, change the color, make it react to its environment differently. So kind of, it's really important just to make sure that kind of all your ducks in a row, you know your materials, and then you know your crucibles. All right, I think we're ready to melt some metal. So I'm going to preheat this, and then I'm going to pull the flask out of here and put it on top. So I'm switching this to casting mode. So now there's a vacuum pulling down through this hole right here. And then I'm going to finish melting the metal, and we'll pour. All right. So besides being, like when you begin this flame, it's like a bright, blinding light, right? Not good for you. It's important to wear glasses because these also emit infrared light, and it'll destroy your retinas over time. So like the mask, having some safety, and I think it's totally fine behind a camera. All right, so I'm going to light this under the hood because there'll be a big plume of soot from lighting the acetylene. All right. And then, so we can see this kind of big, bushy yellow flame right here, and as I add oxygen to it, it's going to shrink down. All right, and what we're looking for is this kind of like soft blue cone. So flame anatomy, like you might think that all the heat's out here, but the hottest part of the flame is actually the end of that really bright cone right here. And then that's what we're going to put in the crucible to start preheating it. I'm holding the torch by the handle here because I don't want to mess with these valves. So I have my metal ready to go, and then also the flux that I mentioned earlier, what's lining the entire crucible. I have another little kind of bowl of it right here. So when I add the metal, I'm going to add a pinch of flux. And what the flux does is it kind of absorbs and eats all the oxygen in that environment. Because again, you don't want oxidized metal going into your mold. Let's see, so how hot is this flame? I don't know, 3,000, 4,000 degrees, right? So, but a really wonderful thing about the metal studio is that you learn to kind of work with it. You learn to like wield this flame, you learn how to be safe around it. And I think a big deal of a lot of craft programs is just like, yes, using your hands, but being comfortable with tools and deducing how to use them, and especially how to use them safely. All right. So if I pull this off, this should be glowing softly, especially on the bottom here. Just once, that's all it takes. So they asked how many times have I burnt myself. So, but never with the flame itself. It's usually kind of touching something that's 1,000 degrees. So in that situation, it's a good idea to use the back of your hand and kind of like sense if there's heat on there. And we got really used to that. I used to work in grad school. I worked in a blacksmithing shop. And if people are forging all around you, like of course if it's bright orange, you don't want to touch it. But also once the steel turns black, it's still 1,000 degrees, so you can't step on it, you can't touch it. You just got to watch out for that. So I'm going to put on some gloves. So inside this kiln, it's 950 degrees, and I'm going to pull out the flask.
Do you use certain fluxes for certain metals? And can you repeat the question?
Can I use certain fluxes for certain metals, or would I? In general, borax is the good kind of overall one that I would use, but there's other like specific ones, like Matt's casting flux, and it still has borax, but it has some other additives to it that might be better for, say, like 18 karat gold or something that oxidizes in a real specific way. All right, so 1,000 degree flask right here. I'm going to flip it over. So I want to show you, so the bottom of that rubber part, it leaves this little hemisphere in the top right here. And this is where all the overflow of metal goes, and that part's called the button. So when I pour and it fills it up to the button, that's a good indicator of a successful cast. So I'm going to put it right over this hole right here. And I'm going to continue to heat up the crucible.
What is an MFA and why is it important to have as an artist?
Oh, that's a great question. Maybe we can return to that. So what is an MFA? Why is it important to artists? And a lot of answers can go into that. So maybe we can revisit that at the end. And please remind me. All right, so this one's a little hotter. So you can see that has a pointed tip. And then also it has this kind of hissing noise to it. So the more oxygen you add to this, the hotter the flame is going to be. Oh, and in general, so I'm right-handed. You want to keep your right hand free so you can maneuver everything, but when I pour, I'm going to switch to my left hand. But this is another thing you get used to with a torch, this kind of like ambidextrous approach to using your tools. All right. This is hot enough. I'm going to pour this in. I'm going to keep heating. I'm going to add just a pinch of this flux. And then as this melts, let me switch hands now. We'll see it go through a couple phases. So at first they're going to clump together. And you'll just have this kind of like immobile mass. So that's not going anywhere. So once those are kind of bonded together, that's what's called sintering. And sintering is when just the outer surface of materials liquefy and they connect together. And then when something's melted, the next step, that's when it's totally liquid. All right, so I'm going to keep this here, but on the back here, so the melting temperature or the liquidus temperature of alpaca is 1652 to 1742, and it has that range because the alloy can change over time. But that's just where it melts, right? So that's the transition area of it. So if you really want to pour the metal, you need to go another 100 or 150 degrees above that. All right, so we can see some of it kind of like moving around here. Pulling together. All right, almost molten. So once it slides around, so imagine like kind of like dewdrops coming together. All right, so that's moving really smoothly across the whole crucible. So I'm going to take this off. And if this starts to smoke a little bit, that means it's getting really hot, and that's the zinc burning off in there. All right, so I'm going to turn on the pump. And I'm going to wait for this gauge to hit 25 to 30, and that's pulling air down through the vacuum. And I'm going to walk this over. I'm going to make sure the spout is hot right here and one smooth pour. All right. Okay, now I'm going to turn it off. Okay, so that went really well. So again, that idea of the button on top here, there's a little kind of like mound where it's the overflow of material. So if that is intact, that means there's no cracks in the mold. It didn't pull all the way through the entire thing. It filled it up. Because one thing that's really mysterious and kind of fun, maybe dramatic about casting is once you invest it and pour your plaster and it goes in the kiln and it burns out that cavity of your wax model, you don't know what's going on inside. And any number of things could happen. So the success rate of casting is not 100%. It could be as low as 75%. I would give it more like maybe like 90 or 95, but there's always the chance that it's not going to work. And it's kind of like the reality of the studio, and there is a little bit of like heartbreak in every studio, and this is a part of it. So again, the benefit of 3D printing, if you really love your design, you have multiples, and you can try again and try again. But if you hand carve something, like that's the only one that's ever going to exist, like exactly in that form. You could have a similar design. So just something like curious to think about. Okay, so if I cut my hands over this, it's a very dull red, and it's not moving anymore, so I can turn the pump off, and I'm going to wait another minute before I quench it. So even at this temperature, so we have, it's less than 1,000 degree flask right now, and then the metal was around, 1,900 degrees. So we're going to plunge this into water. Right, and it's going to hiss and steam, and it's really cool and dramatic. But to me, like one of the best parts is like once it's cooled down, I'm going to like reach into the mold, and hopefully we'll have a completed cast. So I'm just going to pull these over. All right, and this is just a bucket of water. It's lined with the trash bags because pulling wet investment out of a bucket is terrible, right? So it just gives us a way to like transport the investment. And then after that, the investment cannot be used again. So there is this element of waste in this entire process. All right. Good to go? All right, so I'm going to do this sideways. And this way, the investment's going to shoot out both sides. And I'm just going to start dipping it in here, right? So I can feel it's vibrating. It's boiling the water right around the flask. And as soon as it stops, like all that vibration, and I don't hear it anymore, I can reach into this, and here we go. All right. And it looks like we got a great casting out of this. So here we have the button. And then this is that tree branch or tree trunk, so the sprue tree, the part that allows the molten metal to flow down. And this is like a very nice casting. So the detail is really incredible, especially with 3D prints. They're printed layer by layer. And these have very fine, small, detailed layers, and I can still see those. So the amount of detail that comes out in castings in general, like you can push your thumbprint into some wax and your thumbprint would come out. So it's incredibly accurate as to what your pattern is. And then I'll come back over here. So, but to see the whole kind of like lifeline of this, like we'll get our casting right here and we'll cut off the base. So, and that's at this point right here. All the investment is cleaned out. Then we'll do kind of like a pre-finish pre-polish. And in the top here, I've designed the stone setting in there with these like, little tiny prongs. And then at the very end, you'll set the stone, polish things up, and it's good to go. All right, so in the casting room, this is the whole process. So again, like if you were in these classes, you would invest, you would cast, you would carve wax, you would 3D model, the whole gamut. And then this is like extremely accurate to jewelry stores and to industry, and just I think relevant to craft education and kind of like how jewelry works in the world. Okay, so we have time for questions. There's one I want to revisit. So one was, what's an MFA? Why is it important for artists? So an MFA is a Master of Fine Arts. And so is it important for an artist to have one? No, not at all. If you enjoy making art and you can make a living and a lifestyle out of it without any schooling, like go for that. But what an MFA does in a lot of ways, it gives you time to research. It builds a network of peers and mentors, teachers. You get to travel from institution to institution if you're interested in research, like bookish library research. Like that's a great avenue to go. For me, I wanted access to a facility that had forges and power hammers and all these tools I could never have access to. So being in school gives you access first and foremost. And then I wanted to teach. So to teach at the collegiate level, most often an MFA was required as the baseline in order to run a department and to build curriculum, things like that. Does an MFA make you a good teacher, or do you need an MFA to know how to teach? Not at all, again. So it's just a life decision, and it also gives you 1 to 3 years to really focus on a body of work. And until that point, having cohesion in your work and trying to have like your specific voice can be hard to find, and really that community really helps out. At the beginning of all this, I mentioned craft schools. That's another way to gain all this experience. And again, that's another community, and those are usually like workshops that are a week to a couple months. And like in a lot of ways, I love that environment, and it was more impactful to me than say like a long semester. So a balance of both, I think, really fills out skill sets and your way of thinking, and you'll meet like the whole gamut of people in your field. And I think just in the craft fields also, they're not huge. So Peter's community, Kensuke's community, and then especially mine, because I can only speak to that, like I meet my kind of role models and heroes on a regular basis. At conferences, they visit the schools, and that's really rewarding.
Someone said, if I want to try this process, how much investment will I need to make to have all the supplies you are using? How much is the metal, the kiln, and the vacuum cleaner?
Great question. So how much does all of this cost? So used, I would say these numbers I'm about to throw out there, like cut that in half, but used equipment is still expensive. And then there's lots of maintenance to consider too. So, but just to buy everything, so I'm going to move a few things. So kiln this size, probably $3,000. Vacuum caster this size, maybe $1,500 to $2,000. 50-pound bucket of investment, or a 100-pound one, probably $50 to $100. The metal, I mean, you could buy this much gold and it'll cost $1,000, or you can buy this much bronze and it still won't cost $1,000. The wax carving tools, 3D printers, computers, like it's expensive. So that's why institutionally it's really wonderful to be in a school and to participate in that, because those funds are coming from somewhere else. And again, you have that idea of community. And just like one note, like if you're ever going to buy a machine, you always have to remember that you have to like maintain and take care of things. Excuse me. So in here, like you have a vacuum pump, you have these hoses, you have oil, you have to refill it. Who does that, right? And if you don't want to do it, it costs quite a bit. So the art world in general, it's not cheap, like especially jewelry, because like all the tools, which there are many, are small and they can be expensive. So I've been building a studio for like 15 years, and I still don't have all the things that I think I need, but I can get a lot done, so it's a process.
What would you suggest high school students that are interested in jewelry design making?
Oh, so as mentioned before, go to jewelry stores, talk to jewelers. So that's one access point that is available in most any town. And I think people often would be really just like excited that you're excited. I mentioned the Arkansas Museum of Fine Arts, which used to be the Arkansas Art Center. They have workshops, craft schools, summer programs, and things like casting are pretty available. It's one of the first kind of like groups of equipment that a full studio will buy. And especially if you're not doing the direct casting, you can be doing the wax carving. You can be doing the computer modeling. So it's not just this like in the moment pouring liquid metal. Although it's really fun, most of the work, probably like 95% of the work is prep. So I think kind of dig into your local communities, find the jewelers. A lot of towns will have studio artists as jewelers who aren't doing, say, like wedding jewelry, but kind of like their own angle on adornment and jewelry. Seek them out, go to craft shows, go to farmers markets, be curious and be kind of bold about approaching people and starting a conversation. All right, do we have any other questions? All right, well, thank you all so much. I'm really happy that I was able to show you this whole process. And this is a really good, I think, document if you want to revisit it. You can contact the school. I think it'll be online. And I'm available and like happy to answer like emails, or you can visit. And I just love talking about this whole world. So thank you again. Have a good one.